Okay, in this session we'll be working on statistics for data science. In this session we'll be learning introduction to statistics. We'll start with introduction to statistics, and then what are the types of data, what are the sampling techniques, what is descriptive and inferential statistics, how to calculate mean, median, mode, what are quartiles, how to calculate interquartile range, what is standard deviation, and practical use cases we'll see. What is probability and practical use cases. Then we'll move on to introduction to hypothesis testing, hypothesis formulation, understanding null and alternate hypothesis, what are type 1 and type 2 errors, hypothesis example, hypothesis testing roadmap, types of hypothesis tests, and case studies. Okay, let's begin with introduction to statistics. So what is statistics? Statistics is an area of applied mathematics concerned with the data collection, analysis, interpretation, and presentation. That means when we are collecting the data, analyzing the data, interpreting and presenting the data is statistics. Okay, now you have some questions like you and a friend are at a baseball game, and out of the blue your friend offers you a bet that neither team will hit a home run in that game. Should you take the bet? Okay, next question. The latest sales data have just come in and your boss wants you to prepare a report for management on places where the company could improve its business. What should you look for and what should you not look for? Your company has created a new drug that may cure cancer. How would you conduct a test to confirm the drug's effectiveness? So these are the questions. How will you solve this? All through statistics. This is where your statistical skills comes into the picture. Okay. Before going towards deep in statistics, let's understand the data also. So what is data? Again, data refers to facts and statistics collected together for reference or analysis. That means when you collect and store the data, data can be measured, data can be analyzed, and data can be visualized. What are the types of data? Primarily two types of data are there. One is qualitative, another is quantitative. Again, if we further go towards qualitative, it can be further classified as nominal and ordinal, and quantitative data can be further classified as discrete and continuous. Though we'll be working more on the quantitative data like discrete and continuous in our lots of projects and in practical sessions also. Okay, qualitative data deals with characteristics and descriptors that can't be easily measured. That means we cannot measure this qualitative, but can be observed subjectively. Okay, now let's take example nominal data with no inherent order or ranking such as gender or race. Such kind of data is called the nominal data. That means You cannot order it or rank it. This is the gender, other it can be male and female. Okay, the other one, ordinal data with an ordered series, such as shown in the table, which you can see at the bottom right. Such kind of data is called ordinal data. That means, for example, customers go to a hotel or restaurant or go for any product and services. So when their feedback is taken, so it can be good, average, bad, excellent. That means this data with an ordered series is all called ordinal data. Okay, the next one is quantitative data. Quantitative data deals with numbers and things you can measure objectively. So that means this can be measurable. So one is discrete data, also known as categorical data. It can hold finite number of possible. That means it cannot be infinite. Like total number of students in a class. It can be 30, it can be 50. That means it is finite. And the continuous data that can hold infinite number of possible, like for example weight of a person. It can be 15.3, 16, 19, 21, anything. It can be any continuous data. Okay, now let's look into the statistics terminologies. You will find a lot of terminologies like population, sample, and more. Again, population is a collection or set of individuals or objects or events whose properties are to be analyzed. And again, sample is a subset of population, is called sample. That means a well-chosen sample will contain most of the information about a particular population parameter. That means the sample must be a true picture and image of the population. For example, you want to take a sample size of any country. The sample size must represent the true picture of the whole country. That means that must include male and female, young, middle-aged, senior people. It must include the citizens from urban, rural, village areas, remote areas. It must include all religion. It must include, means the data must, whenever the sample size can be 1%, 2% or no, even less, but the data must represent the whole population. Okay, now what are the sampling techniques you need to follow? Okay, the sampling techniques can be mainly probability or non-probability. We'll focus more on the probability, that is random, stratified and systematic. Though there are non-probability also like snowball, quota, judgment and convenience, but we'll focus on the probability. Okay, the first one is random sampling. That means random means it is picked without any specific order. Each member of the population has equal chance of being selected in the sample. The next one is systematic sampling. That means in systematic, every nth record is chosen from the population to be a part of the sample. In this case, we have chosen this second record is chosen. That means every second record, second, fourth, sixth. So that means this it can be the first, third, fifth also, but in this case we have chosen the every second nth record is chosen. Okay, and This one is stratified sampling. A stratum is a subset of the population that shares at least one common category. In this case, it's gender. So in this sampling, random sampling is used to select a sufficient number of subjects from each stratum. So that means in this, we are selecting a random from the male and female subset. So this is called stratified sampling. Okay, what are the major categories of statistics? Statistics can broadly be classified into two types. One is descriptive statistics and the other one is inferential statistics. Descriptive statistics describes data, for example a chart or graph, and inferential statistics allow you to make predictions, inferences from the data. That means the descriptive statistics describes the data and inferential statistics inferences from the data or make a conclusion from the data. With inferential statistics, you take data from samples and make generalization about a population. That means just now you have seen population and sample. That means in inferential you take data from the samples and make a conclusion about a big population. So let's take an example, study of the height of the population. The height can be short, medium and tall. So in the case of descriptive method, record the height of each and every person. That means you are taking the height of every person in the data being provided. So we provide the tallest, shortest and average height of the population. Okay, in the inferential method, we categorize height as tall, medium and short. Take a sample here to study from the population. That means we are taking a sample to infer, to conclude. So what is descriptive statistics? That means descriptive statistics uses the data to provide descriptions of the population, either through numerical calculation or graphs or tables. So here we are taking a example of a t-shirt. So in this is mainly focused upon the main characteristics of data. It provides graphical summary of the data. That means the t-shirt is providing this the size, and which provides the descriptions of the population. Either it can fit in with the minimum or the average or in the maximum size. But in the case of inferential statistics, inference makes inferences and prediction about a population based on a sample of data taken from the population. See, again, earlier it was for everyone, but here it is, the t-shirt is being sized based on the sample size of the population. That means here it is generalizing a large data set and applies probability to draw a conclusion. Which size will fit in? In this case, it can be small, it can be medium, it can be large. It allows us to infer data parameters based on a statistical model using a sample data. descriptive statistics, you are not making a conclusion, but you are describing the whole sample size. But here you are concluding with a solution. Okay, now let's understand how to calculate mean. As you know, mean, in this case, a sample data set of cars containing the variables are given, like cars, all the types of cars, MPG means miles per gallon, cylinder, displacement, horsepower, the real axle ratio, right? All the data is given. For example, if the stakeholder asks for the average or the mean of miles per gallon, so what we can do is take all the data from the variable and divide it by the total number of the records. In this case it is 1, 2, 3, 4, 5, 6, 7, 8. So add this whole, divide by 8, we'll get the mean. That means measure of average of all the values in a sample is called mean. Okay, so how to calculate median? Median is measure of the central value of the sample set is called median. That means to find out the central value of, let's take the example of miles per gallon. To find out the center value of miles per gallon among the population of cars, arrange records in ascending order. That means we arrange this in the ascending order and we need the central value. So in case this is a even, then what we will do, we will take the average of the middle two numbers. In this case it is 22.8 plus 23 divided by 2 equal to 29. 22.9 is the median. In case it would have been a odd numbers of rows, then we would have taken that middle value, whichever that would have been. In that case we would not have divided. Okay, how to calculate mode? Mode is the most recurrent in the sample set. Okay, for example, let's take this cylinder. Here, most repeated number is called the mode. In this case, it is 6. That means to find the most common type of cylinder among the population of cars, check the value which is repeated most number of times. That in this case, it is cylinder type 6. Okay, now what are quartiles? Quartiles tells us about the spread of a data set by breaking the data set into quarters. Just like in the case of medians, we break it into two halves. But in the case of quartile, here the first quartile we have seen, quartile 1 is here, quartile 2 is this one. That means it has been divided into 4, Q1, Q2, Q3. So total 4 has been divided into quarters. Okay, now let's take an example. Consider the marks of 100 students below ordered from the lowest to the highest scores. The first quartile, how will you find out the quartile? In this case, first quartile is lies between the 25th and 26th year. This is the first quartile. So 25th is score is 45 and 26th is also 45. So divided by 2 you will get 45. There are total 100. Quartile 2 is 50th and 51st. So we take the scores of 50th and 51st, which is 58 and 59, divided by 2 is 58.5. Similarly, quartile 3 we get between the 75th and the 76th, which is 71 plus 71 divided by 2 is equal to 71. So this is the way we calculate the quartile 1, quartile 2 and quartile 3. So how to calculate the interquartile range? Okay, interquartile range is the measure of variability based on dividing a dataset into quartiles. Quartile divide a rank or a dataset into 4 equal parts, which you have seen earlier, and here also you can see 4 equal parts, denoted by Q1, Q1, Q2, Q3. The interquartile range is equal to Q3 minus Q1 is equal to interquartile range. So this is the way you can find out. Once you calculate the Q1, Q2, Q3, you can find the interquartile range by subtracting Q1 from Q3 is equal to IQR, that is interquartile range. Okay, what is standard deviation? Standard deviation is the amount of variation in the population data. It is given by sigma. And standard error, it is the amount of variation in the sample data. That means it is related to standard deviation as sigma divided by n, square root of n, where n is the sample size. It is not the population size, it is the sample size. So standard deviation is the measure of dispersion of a set of data from its mean. That means how far it is from the mean. And the formula is sigma is equal to square root 1 by n summation I is equal to 1 to n xi minus mu whole square is the standard deviation formula. So let's see standard deviation use case. Here there are 20 figures. Daenerys has 20 dragons. They have the numbers 9, 2, 5, 4 and so on. Work out the standard deviation. The step 1 what we will be doing to find out the standard deviation is find out the mean for your sample set. So here we have a sample set of 20, total 20. The first one is 9. We'll add and find out the mean. So that means we'll add all the figure, that is 9 plus 2 plus 5 so on, divided by 20, and if we calculate this, the mean is mu is equal to 7. Okay, this is our step 1. The step 2 is for each number subtract the mean which we have found out from the step 1, that is 7, and square the result. That means the first one is 9. If you see 9, and this is the formula, that means 9 minus the mean square bracket, means we have to square it, and 9 minus 7 whole raised to the power 2, and if you calculate 2 square is equal to 4. Similarly, in case of the second, 2 minus 7, 7 is the mean value whole square, and this is a minus result, that is minus 5 whole square is equal to 25. Similarly 4 and so on. So we get the following results in the step 2. What we are doing is for each number subtracting the mean and square the result. So we are squaring the result and we got this. Okay, in the step 3 we are whatever squared numbers hai, Now we are working out the mean of those square differences. That means first one we got 4 plus 25 plus 4 plus 9 and so on, and divided by 20. So our sigma square, if we calculate, is 8.9. And the step 4 is take square root of the sigma square, and if we work out the square root, then it becomes sigma is equal to 2.983. So this is the way we can calculate the standard deviation of any project or tasks